Hey, good morning, Aslan, Alessandra, and Paul. And good morning, Matthias, Linus, Clara, and Malta. Matthias, Linus. Good. And Clara. And good morning, Corey, Stella, Sophie, and Zach. Zach, Stella, Corey. Who did I say? Corey, Stella, Sophie. Good. Thank you for being here early. I'm giving you some points. Good morning, Kai, Inessa, and Amelie. Continuing, good morning, Hannah, Julius, and Isaiah. Hannah, Julius, Isaiah. Whoa, okay. Good morning, Malta, I gotcha. Good morning, Aaron, Liam, and Timothy Peduso. So I got Aaron, I got Liam, Timothy P. Ute, I got Felix and Lauren and Ingrid. All right. I got Ayala and Corsine. Whew, okay, let's see who I don't have. Okay. Do I have, oh, there's a couple more. I have Alessia. I have Sina. Dynamite. I have Anton. Good. Okay. Do I have Leo? Do I have Isaac? Jack? Devante? Cassidy, Alicia, or Isabella, or Ethan? I do. I've got Isabella. She's here. From 9F, do I have Tim? Tim H. Do I have Avram, Ali, Michael, Kiara, or Charlotte? If you are out there, say hello so I can give you some points for participation. Good. Okay, while I'm gathering people, I'm going to start writing. Everybody, can you find your drawing from last time? We were talking about nuclear power plants. And I've got to redraw what I had. You can find your drawing. And I don't remember what color I used for the rods. Ideally, it'd be yellow if you have yellow. But the fuel rods I had down here, so I'm going to redraw some of those. There's a lot of them, but I'm just going to put like 4. Okay. So those were the fuel rods. Fuel rods. Okay, what were they made of? Can you just type in what were the fuel rods made of for a nuclear power plant? so I know that you're out there this morning. Thank you, Alexandra. She's quick on the draw. Uranium 235 is the correct answer. So there's our fuel, U-235. And thank you. Everybody had that. Good. Thanks for participating. Inessa, Ingrid, Amelie, and a bunch of you. Oh, appreciate it. Good. Nice to have everybody awake. Isaiah, Corey, Sophie, Aaron, good. Let's draw then these upper rods, and I think this is where we got to last time. Am I right? We had some upper rods that kind of fit in between here, and I wrote them like this, and I don't think we talked about what they did. Anyway, these things, let's attach them to the ceiling, okay? And we said they can be raised and lowered. And I'm going to write that over here, or I'll write it up above. Can be raised or lowered. Did I tell you what those are called, those upper rods? And I've got another person. I got Charlotte. Good. Thank you, Charlotte, for checking in. Did I tell you what those upper rods were called? Control rods. I did. Okay, so let's put the name up there too. So these are control rods. And can you guess what they do? Can you guess what they do? By the way, down below we had, this had water around it, the fuel rods, and then we had the edge of the chamber here. What do you suppose the control rods do? Yeah, could you be a little more exact there, Liam? Control what? Control the neutrons. Yeah, a little more exact yet. You're getting warmer. They can control the temperature of the steam indirectly, so keep going. Regulate the energy. Yes, good, Alessia. And how do they do that? Yeah, okay, Zach. The neutrons jumping back and forth. They regulate this. Okay, you ready? So you're all on the right track, okay? There's Michael. Good. Thank you, Michael. Okay, so darn it. Sorry, I had a little meltdown myself here in the control room. Okay. Here we go. Got another person here. I got Abram. Yeah, I know I'm blocking the way. It's a small studio. Okay, so here we go. The control rods absorb neutrons to control essentially, as Alessia alluded to earlier, control the amount of energy produced. Okay. Control rods they're made of several different things, but one metal that they can be made of could be cadmium, Cd. So control rods can be made of cadmium. Why? Because cadmium, like some other metals, absorbs neutrons, okay? They're incorporated into the nuclei of cadmium. And I don't know why that is. I don't know why that is. It's beyond what I learned. Okay, so far we've got neutrons flying around. We agreed on that. And neutron is N0, so I'm going to put some N0s flying back and forth. And that makes nuclear fission happen, right? So this is a fission reactor. Did I tell you that already? Fission reactor? Nuclear fission reactor. Nuclear fission. I might have written that last time, I don't know. Or sometimes we just call it an atomic reactor, okay? All right. Okay, so let's talk about the control rods for a second. So here's the fuel rods, here's the control rods. So it kind of works like this. Oh, I'm running this for the Netherlands, okay? We need more power. We're gonna pull up the control rods completely so that more neutrons can go back and forth. We need more electricity. It's a high time of day for electricity use. Okay, now it's middle of the night. I'm gonna put the control rods down in here and slow down the amount of neutrons that are going back and forth and lower the amount of energy produced. Okay, so literally they're raised and lowered to control the amount of energy. Okay. If it's an emergency, what do you suppose happens? If it's an emergency, what do you suppose happens? So type in there, what do you think? It's an emergency, what happens? They put them all up. No, not up, Liam. Isaac is here. Good morning, Isaac. Aslan, they close completely. I don't know what you mean. What do you mean by close? Put a little sign on the door, close for business? Just giving you a hard time. What type of emergency? I would say something that is an emergency that affects the power plant. We'll talk about what they are exactly. What do they mean close and dumped in the water? Michael, I don't know what you're saying. Michael, be a little serious, okay? They put them all down. What are them? They close, huh? Guys, don't just retweet something that someone else wrote because it's not really helpful. Try not to use it and they. Can you use like the vocabulary words so I know what you're talking about? The water cools the rods. It does a little anyway, although to be honest, not really not. Huh? The water is heated up by the fuel rods, so the water is going to get hot. They shut them down. Well, what are them? Push them fully down. Folks, let's not talk about them because them could be a number of things in this picture. The go down all the way. What go down? Put them down. Hello, I'm looking for someone who can write a sentence. No one can. Drop the cores in the water. No, cores are already in the water. These are the cores. Fuel rods are called the cores. The rods get down. Which rods? We got two rods. We got fuel rods and control rods. Someone used the vocabulary. Still waiting for someone to write a good sentence. No one can do it. This is so sad. They lower the fuel. They don't lower the fuel, Aslan. They don't lower the fuel. Okay, Isaiah, the control rods get pulled down, or in this case, like gravity, they let them go down. The control rods. Ah, okay. So if there's a nuclear emergency because of an earthquake, a tsunami, a political crisis, an accident, as we'll find out happened in a certain plant in Russia at the time. Okay, so what happens is these automatically go down. Okay, so some runs see beep beep beep. They go the control rods go down automatically in between the fuel rods. Okay, sorry to be a pester, but I want you to use the new words: control rods, fuel rods. Okay, and it cuts off the amount of neutrons going back and forth between the fuel rods. Okay, good. You're all warmed up. Thank you for persevering. And I got some good comments towards the end from Clara and Aaron. And Tim H is there. Let me write down Mr. Hartling is with us. Okay. Still looking for Allie and Kiara. And Ethan, Alicia, Cassidy, Devante, Jack, and Leo. If any of you are there, let me know. Devante can't comment on the live. Is he there? Hannah, can you text and find out for me? Okay. Thanks, everybody. Okay, now let's draw a little more of our picture. All right? So here's what's going on. You ready? The hot water goes out like a tube here. And I don't have much of a whiteboard, so I've got to kind of draw this cryptically, in other words, in a small way. So this is hot water. Hot water. And it's water that's been what? Heated up by the fuel rods, by the fission happening. Remember, that's exothermic. It gives off heat. So in addition to the neutrons flying around, I get a lot of heat given off by these fuel rods. Maybe I can put some little heat markers here. So they're warming up, huh? That's supposed to show warming up. I don't know if my cartoon is so good or not. Maybe you get the idea. Okay, so the water is super hot, okay? I mean hot, hot, hot. He is here? Okay, thank you. I'll write him down then. All right? Thank you for telling me. Sometimes I know Devante can comment because I get his comments, and other times I know he cannot. Thanks for telling me. He's been marked present. Thank you. Okay, so here comes the hot water. Now, the hot water cannot do. There he is. Okay, good morning, Devante. The hot water cannot directly do its little next job. Here's the problem. The hot water is also radioactive because it's been sitting next to some radioactive fuel. Hot water. I'll write here above it, radioactive. So what they do is, folks, something that's pretty clever, okay? They have this water system go into another water system and kind of loop around here. And then come back out and probably eventually go back in, but we're going to worry about that in a little while. I don't know if that's really true. But what this is called this little part here is a heat exchanger. heat exchanger, and it's also filled with water. But it's filled with, you guessed it, non-radioactive water. You see where I'm going? Non-radioactive. Oh, how am I going to fit that in here? Water. I'll write radioactive as rad. I bet you'll know what that means later. So think of this. Here comes this water and goes this way. And in the meantime, this other water heats up. So this water heats. Water heats up. Heats up. So in the heat exchanger, the hot water coming from here heats up other water over here. The reason they do that is they want to keep the radioactive water that was by the fuel rods, they want to keep it away from people. And this other hot water, you ready? We're going to make a hole here. And we're going to show that coming up here. And we're going to get to something that you might have learned about last year, I hope. Sorry, I don't know how to do this because I got to like turn it around here. And it's going to go to something that we'll study at the end of the year. If you didn't have it last year, it's called a steam turbine. And a steam turbine spins really fast, and it spins something else we'll have later this semester called a generator. And the generator, as it spins, makes electricity. So this is going to be steam. So make your pipe, the water's going to change and get so hot that it becomes steam. And then I get something called a steam turbine, and it looks like this. And I'm going to write in your steam turbine. And it spins, okay? It's got like a rod going through the middle. And it spins about 60 times per second, okay? It's attached to a generator. And this thing also spins. So here we go. And oh man, I know my drawing's getting involved. Generator. Generator. And what we get out of that is, I'll put the symbol for electricity. I'll put a light bulb, okay? So electricity is made by generator. Okay, now, I know I'm writing a lot and it's probably hard to see. Let me pull this over so it's maybe a little less in the glare of my lamp. The steam comes into the steam turbine, if you didn't have this last year, and the steam turbine spins really fast. And it's attached to the generator, which also spins. How fast is this spinning? Like I said, like 50, yeah, it's not 60, I think it's 50 times a second. So it spins 50x per second. The steam turbines are big. They're several meters high. They're something like Siemens would make, the German firm, okay? They're really highly technical piece. And they spin really fast, and they're connected to a generator, which then spins really fast, and it makes electrical current, which is called 50 hertz current. And it's the stuff you use in your outlet. When you plug in like your Akku to charge, or you plug in the water cooker, you're using power generated from a steam turbine and generator at some sort of, if it's not a nuclear power plant, then it's a coal burning power plant to make steam by burning coal here in Berlin. Okay, so we don't have this, but we have coal that's burnt to make the hot water and make the steam for the power plants in Berlin. Okay, so it's a different source, but I still get steam out of it to run the steam turbine, the generator, and to get electricity to you and I. Okay, let's see if you have comments or questions. So it's a pretty amazing system. And it's all about making steam so you can make this thing spin really fast. Isn't that crazy? The whole point of the steam is when I put it in here, the steam generator goes like crazy. And so does the regular electrical generator, making electricity. Is it magic? No, it's physics. We're going to learn how a generator works probably in like April or May. Okay? We're going to learn how that works. So I can't quite show you everything now, but we will. So keep that in there. Okay, let's see. Yeah, that's right. Okay, good. So our comments are all okay. Questions from you about this so far? I know it's pretty involved, but I can't help that. It's pretty impressive technology. It's not real new. You know, they started these after World War II. Once they dropped bombs, the bad stuff, then in the 1950s, they figured out how to make nuclear power plants, which, although it has problems, certainly has been more beneficial to humankind than dropping bombs, right? Now, let me tell you what's going to happen here. What happens if there's too much pressure? Thank you, Alessia. Good question. If there's too much pressure, especially back here in what's called the reaction chamber, you can get an explosion. That happened at a couple of nuclear power accidents, which we're going to talk about. Chernobyl in the former Soviet Union, which is now Ukraine, and Fukushima, Japan, after the 2011 earthquake there and tsunami. So we're going to talk about those. But there's a couple other accidents earlier. Windstar in England and 3 Mile Island in the United States. They didn't blow up, but there were problems at both plants. Can nuclear power plants cause harmful radiation? The short answer is yes. Okay. Where it killed probably the most people, Aslan, was the accident in Chernobyl in what is now the Ukraine during the time of the Soviet Union in 1986. A lot of people died there of nuclear radiation poisoning because of the plant partially exploding and because of the rescue efforts that people tried to do. It was a waste of a lot of lives, to be really honest, Aslan. Okay. Good. Here's where we're going. Two things. I need to talk to you more about the accidents and maybe how this looks in general. And I also need to send you an assignment. Now, I don't have the assignment done. I sent you part of it, but I got to put in the questions for you. It'll be due Friday. And it's a person's blog I found, a student from the Netherlands. And the blog has a really nice little diagram of this, so you can see this a little easier, I think. And it also has some good, interesting comments about what the student thinks about nuclear power. I'm not for or against nuclear power, to be honest, 100%. It's not perfect, but it's probably something our world needs for a while to get away from some of the problems with coal burning power plants. Okay? All right, so you got an assignment coming, and that will have some easier, perhaps, to see drawings on this. And if there's not enough pressure, will it not work? It's not really about pressure. It's about heat, Devante. So I gotta get the water here hot. The water is swimming around the fuel rods, and if the water gets hot enough, it gets to be steam, and then the steam goes up and runs the turbine. Now the steam, Devante, is under a lot of pressure, but that's not really much of a problem. That's not hard to get. So you just have to heat the water up a lot, and it's all about getting the water hot to turn it into steam. And then you have enough steam to run the steam turbine, essentially. Other questions from you? Other questions from you? I'm going to erase all this and make it on a smaller or bigger scale so you can kind of envision how a nuclear power plant looks. Okay? If you've ever watched The Simpsons, you've probably seen like a cartoon version of a nuclear power plant. We're going to see why that's there. Okay, you ready? Away we go. So much to tell you because it's really pretty cool. So much stuff going on. Okay, so let's talk about a nuclear power plant. So really we're talking about all of this happening in this would be the reaction chamber, RXN. And this is called a containment area, or sometimes called a human shield. In other words, all that stuff with the nuclear fission happening, that's all happening in here. Okay? So that's all going on in here. I could show some pipes coming over to the heat exchange unit. Maybe I'll do that in red. Heat exchange unit. And we said that's sending steam then up to here. So we've got the and attached to that is the generator. Drawn very poorly. Let's try it one more time. Come on, teacher. Wake up and smell the coffee. And this is turning a lot. This is turning a lot. So again, these two were the steam turbine. And it's several of them, okay? Steam turbines and generators. Okay, now I got to tell you too, when the water comes out, and I don't know, I'm going to draw this. When the water comes out of the steam turbine, okay, that steam has got to cool. It's still pretty hot. Yeah, that's the word plant, power plant. So the water's got to come over and go to one of these, and you're going to notice this from The Simpsons probably. You ever see this sort of picture? This is called a cooling tower. And it's like well, you've seen them probably, right? There's a couple in Berlin as well. And so they're not just for nuclear power, they're used in standard power plants as well. Once you get the steam, the water's still too hot. You can't like let it out in the local river or you'll boil the fish. Okay. So they got to cool the water down before it can be released into a local stream down here. Okay. And they're always on some sort of water because some of that steam, sorry, that's the word stream. Okay. Stream, I'll write, or lake. Or it could be the ocean. At any rate, you got to have a place you can let off that cooled water. The water tower has this shape because it's the most efficient shape. So it's like a squeezed in can and then let out again at the bottom. It's the most efficient shape for releasing heat. Releasing heat. If I wanted to keep heat, I would make a ball. That's the best way to keep heat. But if I want to release it, I make this shape for like the Homer Simpson cooling tower. Okay? Have you seen those around Berlin? Have any of you seen those around Berlin? There's a couple of different spots you've seen them maybe. Spandau. Spandau. Okay, so if you've been up by Spandau, you've seen one for sure. That's a cooling tower. And there's a couple others in Berlin as well by the power plants, okay? By the way, if you live down in Teltow, where I used to live, in Lichterfelde Süd is a power plant there, but it's coal burning. Coal burning. I think they still have a cooling tower. I haven't been there in a while, but I think that cooling tower is still there. But it's coal burning to make the steam, to run the steam turbines. Okay? Okay. All right. So many of you have not. So look for those when you're out in the world. If you see a cooling tower, it doesn't mean it's a nuclear power plant, but it's some sort of power plant that uses steam generators. Okay? You'll see that in the world. Yeah. Okay. All right. All right. Good. Let's talk about, while I have this stream here, I want to talk about one problem of nuclear power. So I cool the water down, but it's not down to like the temperature of the lake or stream. It's still pretty warm. So I'm going to give warm water into a lake or stream. Can you guess why that's not really so good? Yes, near Obi, Alessia, there's a power plant, right, near Obi in Lichterfelde Süd. So this gives out warm water into a lake or stream. Why is that not really a good thing? And by the way, it's called thermal pollution. You can write it down here. I think I'll write it in red because it's not so nice. Thermal pollution. Why is that not good? Yeah, and even if it doesn't, Alexander's right. Even if it doesn't boil a fish, it's not that hot anymore because it's been through the cooling tower, but it's still artificially warm. It's not a natural environment for the fish. For example, if you saw this area near the cooling tower and saw the canal where the water comes in from the cooling tower, it did not freeze a couple of weeks ago. That canal did not freeze. Why? Because of the warm water coming from the power plant. So it's artificially warm. It might even attract fish, but it's not what is supposed to be happening. It's not part of nature. Let's see what other comments you have. Yeah, it warms up the temperature of the lake too much. Right, Devante? Good. Yes, Charlotte. Fish and plants, they can adjust to it, but it's artificial. And some fish can't live in this warm water, by the way. No, it's not about the electricity. The electricity is not going into the lake. That's not a problem, Alessia. It's about the warmth. It changes the actual temperature of the environment. Yes, Isabella, and that's really the problem. And all the ensuing problems that have to do with the fish and plants, as Charlotte alluded to as well. So all of those are problems with thermal pollution. So even if we don't go and talk about the rest of the pollution, which we will, thermal pollution is by itself a problem. Okay? All right. Before we get to nuclear accidents, let's talk about nuclear waste. So nuclear waste is a big issue. And it's the garbage or waste from a power plant when it's done working or something needs to be replaced. So waste from nuclear power plant. And the problem is, really, the waste from the nuclear power plant is still a bit radioactive. And we know we don't really want to have that like near us, right? So it's not radioactive enough to use. I can't get more power out of it. It's just too low level, but it's still high enough to be dangerous. And really, there's high level and low level nuclear waste. Can you guess something that when it needs to be replaced, the ones they throw away are going to be in the high level? Or do you think there might be something else that when it needs to be replaced would probably go under low level when they throw something out? Can you guess something and tell me if you think it would be high or low level, something that needs to be replaced? So give me the item and then tell me high or low. I'm going to read your comments too. Yeah. Tim Hardling asked if there's a way to get more energy out of the waste. Generally, Tim, not. It's just too low a heat. I can't heat up water with it anymore. So no one's figured out a good way to use it. So it just has to sit there for a long, long time, thousands of years. Okay. Inessa writes the fuel rods, and so does Alessandra. The fuel rods would be high level. Yes, used. And if they're used, we call it spent fuel rods, like they spent all their money. So thank you, you two. You're exactly right. Those would be high level. Spent fuel rods are definitely high level. Let's see what else we have. Control rods. Yes, Ingrid. Spent, or let's call them, they're not spent because they're not fuel used. Control rods. They're so close to the nuclear power rods that they also are still pretty radioactive. Well done. Good, folks. Let's see what else you say. Good. Fuel rods. Isaiah had that as well as Malta. And the water would be low. It depends on the water. We got radioactive water, Devante, and we got the secondary water that would be that would be low. Let's write here the secondary water that actually goes through the steam turbines. That would be low level. Let's call this other water the primary water, Devante, the one that's really being heated by the uranium rods. So if I have primary water and I've got to somehow change that, the old stuff's going to be radioactive. Good. Anything else? Generator high. No, the generator, luckily, Charlotte, is far enough away from the reaction chamber, and it's only got it has no actual radiation that is touching it. So generator would be low. So a used generator. Or a used steam turbine, pardon me, would also be low. Okay? The heat exchange unit in the nuclear power plant. Yes, Alexander, that's probably going to be high. So if I have to change the heat exchange unit, if I have to exchange for a new exchange unit, there's a really bad, complicated joke. Once it gets old, that's probably going to be high. Thank you. Good thinking. The steam turbine low. Yes, good. Exactly. I put that over here for low. Thank you, Alessia. Let's see what others said. Um, yeah, like I said, generator probably low. It generates electricity, but it's not generating nuclear problems, nuclear waste. Okay, it's pretty far from the fuel rods and stuff. Okay, a lot of other low stuff would be like pipes that need to be replaced, pipes, concrete. But it depends. Sometimes if it's really close, like if it's part of the human shield or biological shield, that would be high level. So a biological shield concrete. So there's a lot of stuff. And holy smokes, our time is over. We'll talk more about nuclear waste next time. We're not done with the idea, but that'll get you at least started. Okay, I'll send that assignment to you and you can have a look at it. But I think we're doing just fine with nuclear power. Have a good rest of your day. Is it possible to combine waste? Not really, Tim. I don't think so. You'd want to keep high and low separate. Okay, thank you. See you later in the week. Bye bye. Stay healthy.